Hello and welcome to a series of short talks about electrons and electrons in solids. At a very fundamental level, the entire subject of electronics is about the movement of electrons. So a good place to start is, what exactly is an electron? Well, an electron is a fundamental particle of matter. It has a mass of about 9.1 times 10 to the minus 31 kilograms and a charge of minus 1.6 times 10 to the minus 19 coulombs. The fact that electrons are negatively charged is a rather unfortunate accident of history. Back in the early days when they were investigating voltages and currents, they had to make a guess about the charge of the particles which carried the current. And they guessed wrong. 50-50 chance they got it wrong. So now when we talk about a current going in one direction, what's actually happening is a whole load of negatively charged electrons are going the opposite way. This has confused every generation of students from then on. Welcome to the club. Another thing you should know about electrons is that in the atom they exist outside the nucleus, the central part of an atom where most of the mass of the atom resides. Atoms have a nucleus which is positively charged, and these negatively charged electrons orbiting around it, so that the entire atom is neutral. Thinking of electrons as tiny point charges which rotate around a central nucleus is the so-called classical model of an atom, sometimes called a planetary model because it's similar to planets orbiting around the sun. But that's really not a very good way to think about electrons and atoms. A much better way is to think about electrons not as point charges, but as spread out. And you can describe them in terms of the probability that an electron would be found at any particular place at any particular time. If you plot those probabilities, you get nice, interesting pictures like this. We won't be doing the maths of deriving these pictures. I will leave that to the physicists and for anybody wanting to study solid-state electronics later in the degree. For now, having the idea of an atom having a positively charged nucleus with these negatively charged electrons spinning around it is a good enough approximation. Electrons don't always appear as part of atoms, however. They can appear by themselves in free space. It's rare, but there is a place only about 50 miles away in which there are literally billions of electrons just hanging around by themselves, not orbiting around the nuclei of atoms. That place is called the ionosphere, and it's straight up. And up until about 100 years or so ago, nobody knew it was there. It does have the very useful property, however, that you can bounce radio waves off it. Those electrons arise because of very high energy particles that come off the sun, bump into atoms at the top of the atmosphere and knock electrons off them. And since there are so few atoms at the top of the atmosphere, those electrons can hang around sometimes for days until they find another atom to bond with. This is something which they will do if given the chance. Free electrons are very reactive, and if a free electron comes across an atom, a neutrally charged atom, that the Na here represents a sodium atom, they will bond to it and form a sodium atom with an additional electron, which means this sodium atom now has a net negative charge. It's called an ion. But the electron is in a lower energy state as part of an ion than it would be if it were in free space. Now back to this classical model of atoms, with these electrons orbiting around this positively charged nucleus. The nucleus actually contains two different types of particle, the positively charged protons and the neutral neutrons. but the negatively charged electrons are orbiting around. Now, since the nucleus is positively charged, the electrons want to be close to the nucleus. So the electrons are losing energy. They're like dropping down as they get closer to the nucleus. It means that the electrons further away from the nucleus have more energy. And these electrons further away from the nucleus will try and drop down towards the nucleus if they can. But they can't always do that. To understand the reasons why they can't do that, we have to do a bit of quantum mechanics, and I'll leave that until the next talk. For now, the important thing to bear in mind is the closer to the nucleus, the less energy the electrons have. The further they are away, the more energy they have. That was a very quick introduction to electrons. Next time, I'm going to look at some of those results from quantum mechanics, which turn out to be very important in determining the behaviour of electrons in atoms, and in particular why all of the electrons in an atom don't collapse down to a very low energy state very close to the nucleus.